the average, we like to use the word mean now, over the long run, when samples are repeated many times. Are repeated many times. Okay, so what does this even mean? So for example, we could figure out the expected value of a lottery ticket of, gambling of some sort, so like blackjack, really any gambling. Maybe insurance payouts. So this is really helpful to know because this determines how much like a company would maybe charge you to play a certain game or charge you for insurance, like car insurance, to make sure, of course, that they make a profit. So this concept can be applied to anything that has a cost to play. And payouts, so like insurance companies, that are designed based on relative probability. And so that's why we've already discussed probability. All right. So let's get to the math behind this. There's one thing you need to know is, another definition, is the probability distribution, or I could call it the probability model. And that's what we're going to be looking at throughout this entire unit. So what it is it's a table listing all possible outcomes and their corresponding probabilities. I wish I gave us more space with these lines. Key thing is your probability distribution, or I could call it probability model, has to add up to 1. So that's important. So when you're looking at your My Open Math homework, you will, in the homework, it will say, is this in fact a probability distribution? Or they might say a probability model. And how you check for that is to make sure all your probabilities add up to 1. So let's get to an example. Here is a probability model, okay? I'm listing all the possible outcomes and their corresponding probabilities. And so this is a lottery ticket. And on the lottery ticket, let's say it's like a scratch off. That, these are your only possible, and this should have a $sign. These are your only possible outcomes on this lottery ticket, okay? So there is no $5. It's just $1, $10, $50, $1,000, or you get nothing. And here are all the probabilities of winning that. So I want to find the expected value for this lottery ticket. And so what you do is you take the outcome and you multiply it by the probability. And you're going to add all of these together. And don't forget units. So now it's $50. Well, there's 1 in 100th chance you win that. And then it's $1,000, and it's 1 in 2,000th chance winning that guy. And then what do you know? It's a really big chance to win nothing. That's how they get us. Now, I want to make sure we're clear that if I took the time to add all of these probabilities together, it will equal 1. All right, so in your calculator, just make sure you're careful putting it in, because of course we can make silly mistakes. I'm a queen of that. But I'm going to just save us a little time instead of me going to Desmos and typing this all in, or Excel or Google Sheets, whatever you feel comfortable with. And if I put all of this into a calculator, and maybe you want to try it to make sure you put it in correctly, it's going to give me $1.40. Now make sure you're careful with units. You know, it's not always going to be money. So it could be some other units. So you want to make sure that whatever your outcome is, whatever units those are, that would be your unit for expected value. So what that's telling you, okay, is that, let me change colors for us. On average, the player can expect to win $1.40 because it's positive. Now that's saying if I played over and over and over and over, okay? So that's when, you know, the definition of expected values is when your samples are repeated many times. So that's not saying like I just play once and I'm going to win $1.40, okay? It just means over the long run, you have the expected value of $1.40. And so what the lotto ticket people do, they're like, okay, well, if that's the case, let's jack up the price a little bit. So then on average, they're going to make a profit. So if you pay $2 for this lotto ticket, what are your expected net winnings? So this is very similar to taxes, like your net earnings. So it's going to be, so your net winnings, just to refresh your memory, it's going to be after the after cost of playing. Okay, so what you're going to do is you take your expected value always, and it is this order, and you're going to take away how much the lotto ticket was. And what do we get? We get a negative 60 cents. And so what that means is, let me go ahead and get fancy in another color. On average, the player will lose, because it's negative, 60 cents per game. And just to be ultra clear, over the long run. So again, you could go and buy a lotto ticket and hit it big and you just got lucky. But if you keep playing this throughout the year, you on average will lose 60 cents per lotto ticket that you buy. Because remember, you could win big and the next, 10 times you lose and so forth. All right. So let's just make a little